Let us see how to dynamically allocate memory from the heap using pointer. So if I say integer star p, then pointer will be created, then assign new int of size 5. So an array of size 5 will be created in heap. Then if I want to store some elements, I can store them. P of 0 assign 12 and p of 1 assign 13. So in this way I can store some elements. Then if I want, I can display the element also, that is p of 1. I can access it just like an array, and also I will say endl. And if I don't want this p, then I should not make p assign null. If I make this, then the pointer will no more be pointing on this dynamic memory. So instead of this, first of all, I should delete this array, then I should make pointer as null. And one more suggestion is, in modern C++, don't use null null, but use null ptr, null pointer. So this is a built-in literal that is meant only for the pointer. So if you want to make a pointer as null, then use this literal. So this is how you can create an array in a heap. Let us see what is the benefit of having a array in heap. See, suppose I am declaring an array of type integer of size 10 in my program, then as long as my program is running, this array will remain of size 10 only. This array cannot be changed. Later on, I cannot say that I want an array of size 20. There is no syntax available in C++ for changing the size of a existing array. Then the problem is, if I directly create an array in my program of some size and give it to the user, then user may be having different number of elements. If they are more than 10, then it will be difficult for user to use my program. I want to create an array depending on the number of elements a user is going to store in an array. So for that, I'll take size from the user. I will say cout enter number of elements that he is going to enter. Then I will read size. Then later I will create an array of this size. So okay, this is also good. Now my program will be creating an array that depends on the requirement of the user. Let us confirm the size of an array here. I'll use size of operator for a and also endl. Let us run this program and see. Now here the program is asking enter the number of elements. So I will say I want 20 elements. Now size of has displayed the size of an array as 80. Reason, it is of type integer. Array I am creating of type integer, so it is 20 into 4 bytes, so that is 80 bytes. Again I am trying for different size. I'll give the size as 5. Now this time an array size is 20 bytes because 5 4s 20, so it is creating an array of size only 5 integers, that is 20 bytes. So now the problem is solved. Whenever the user uses my program, he will give the number of elements and that size array is created. So as a C++ allows dynamic declaration, so this is possible for taking the size from the user and creating this array. Now basically this array is created inside stack, and here we are taking the size of an array, then we are creating it inside the stack. So this is good. But again, afterwards, again I want to change, suppose size as 35. Then I say I want to create and change the size of this array to new size. So there is no syntax available for changing the size. I cannot change it at all. There is no syntax. So once an array is created within a program of some size, then it cannot be modified. And this array is created inside stack. Suppose I want to modify the size of an array as and when required. I may be taking some size, then again I am reducing the size or increasing the size of an array. Then I want a dynamic array inside heap. So let us see how we can do this. Here I am already asking for the number of elements, that is I am taking the size. Then I will take a pointer and create an array. I will say new integer of size. So now I will get an array of given size. Then after using it for some time, again I can ask cout enter new size. So I can ask for size again, and cin I will take size. Then I want to modify the size of this p. Right now the size of the p is whatever is given initially. Now I want to modify it, so I can take the size again. Then I will say p assign new int of size again. So it means I can create a new array again inside heap with a different size and assign it to p. Initially it was created for the given size, then later a new size is given and an array of new size will be created. So I'll make it simple. Instead of doing it like this, I'll show you in a simple way that suppose I will take a pointer and I will create a new array of size 20. Now this is an array created with some size 20 in heap. Now later on in the program, if I want a new array of larger size, that is integer of size 40, I can create it. So now the array of size 40 will be created in heap, and same pointer p will be pointing. Now here if I access p, like if I say p of I, then I can take I from 0 to 19, and here if I say p of I, then I can take p of I from 0 to 39. So now the size of an array is greater. With the same pointer I have created a larger size array. So this is the benefit of having arrays inside heap or dynamically creating the memory. But one more important point is, here already I was having an array of size 20. Then later on I am creating a new array of larger size, that is 40. Then what will happen to this existing array? So before changing pointer p to point on the new array, I should delete p and then create an array of larger size. So this is a good practice, otherwise this will lead to a memory leak. So this is an array of size 20, then later a new array of size 40 is created, and this is no more in use. So before that we will delete it and use it. So having arrays inside heap is with the help of pointer, is that pointer remains same, and that pointer can be pointing to any size of memory, maybe one time 20 size of array, then later on 40 size of array. This is the flexibility that we get with the help of heap. So our programs can become more dynamic, and during their runtime they can change the sizes of the memory, or they can make the pointer point on different size memory. So we will be using this further in our programs. This is just the introduction about the heap memory. Later on we will see a lot about heap memory and the pointers.